If you want to be performant, sometimes you also can save with textures, because super many megabytes you usually get with textures if your model is not overly exaggeratedly strong in topology. If you use mediocre or even low poly models, then those have usually just like 100 kilobytes or so, but textures quickly go up the megabytes. I have here a program, Texture Assembler, that I like to use. I show you an example. It is a very little tiny program, and you can drag and drop any texture in here, and then you see the single channels. Every texture contains red, green, blue channels and an alpha channel. Alpha is something like transparency. You can see it if we use this pine tree here. Then you see the red, green, and blue values of the pine tree, and then you see this weird mask. And that means everything that is black is looking through, it's transparent, and white will be solid. And gray would be semi-transparent, like glass or something like that. This program is interesting because you can, for example, you can resize it. You have here the width and the height of the texture. Usually you use multiples of, for example, if we again choose this texture, we have 1024. This is a 1K texture and is the standard for most of the things out there. If you are, for example, using a texture as an atlas with many tiny textures on it, 1K might be a bit too low, and you go up for 2K. Then you just double this. Usually you have then 2048 or 4096. Unity usually is chill. It doesn't matter for Unity because it will be translated into a stretched 1-to-1 ratio texture. But Unreal, for example, will definitely cause some problems if you not from the beginning on use textures with a 1-on-1 ratio. And the best practice, usually people use numbers that are binary, like 512 to 512 for bigger icons, or for not so important light maps, or for very tiny objects. It often is a matter of, for example, this little thing of a street. Usually I would say, how wide is a street here? 3 meters? So the full thing here can be 6 meters. Or is it just a carpet in a child's room and it's just a meter? You have to know how big, how many pixels of your monitor will show singular pixels here of the texture. A tree can quickly go up to 20 meters. If you go close to it, it looks like shit. But do you want to upload a tree that would look nicely this close? This tree is something you would, if just put in the far distance. Yeah. A tree would contain of different textures like tree bark and leaves. And those are usually tiled. Like this is tiled. Tiling means you can have a texture and you could just copy it above and it would seamlessly go into, it would kind of keep the flow. You see that when you go out of the picture up, you can also go in down, and it would be always the same street. You can tile it into infinity. It doesn't make sense to the side, but it is possible. If you do this to the side, then you get a wider street. And this is usually the thing with those kind of textures. The texture assembler. I just want to point out that something texel density is the word we use in the industry. That means you should look how much space the texture will take on the object in the world to decide how high the resolution of the texture should be. For example, also the platform on which you play is important. Maybe your phone or a Switch is not so powerful like a PS4 or 5 or even a PC. You can go wild on the PC. Why do I even use this program when I quickly need to change textures or stuff like this? I mean, this program is interesting to show you a few things about textures. Usually you have JPEG, then you can just have red, green, and blue, or you do PNG, then you also have the alpha. So if your picture needs a transparency in the picture, then use PNG. This program can create a new texture or resave and override the old one. And you can also combine the channels. For example, this here, white means the whole street is there. There is nothing transparent. It makes no sense to be transparent as a street. But if I click I for invert, then it gets black, and black means everything's gone, then no street anymore. Everything there, everything gone. Black always is a 0, and white is a 1. It is a normalized math in the background that tells the shader later how to show this. The shader is kind of the program that computes how textures are displayed on surfaces of objects, the assets. Yeah, and you see here a different pack of textures that kind of looks the same. Everything is a street, but it is different. And in the end, it should look like this. Very realistic. This is called physical-based rendering, or PBR, and we have that since 10 or 15 years in the gaming industry. In the beginning, we just had these textures here that just is like painting on a surface and make it look nice. With a street, it's easy because a street is kind of 2D. Yeah, you have it on a surface. But if if an object has curvature and topology, differences in height and stuff, then these textures will wrap around. It's also called UV unwrapping. Then you kind of cut the whole picture on certain places, usually on places where you can't see it, like on the underside or the backside, and the texture will wrap around the object. But if the street is completely flat, maybe it's just two triangles that cause one quad, one little plane, and the street is on there. And then in the game, you sit on the street and you see it's just 2D. But usually these markings would be a bit higher than the surrounding. And for that, you need physical-based rendering. It means the object is not changing, but the texture makes it looks like. Kind of the whole material. Material is the name for a set of textures that together cause a more realistic effect. This here, for example, is called height. And it just means how high is the stuff from 0. And you see that these markings are a bit more wide, so a bit more upwards than the rest. Way more common is this here. It is called a normal map. And this is not the height, it is the direction. When you see something like this is kind of a pale, weird bluish. You have an R, G, and B. It usually is not containing any A. Of course not. It couldn't be a JPEG if there would be an alpha in. But it means red, green, and blue will be translated in X, Y, and Z axis. Every single pixel has these values and are showing into the direction X, Y, Z, Ys of the RGB values of this pixel. You may ask, why? Because even if a surface is just topology-wise one thing that has no bumps, no topology, this here fakes a direction of light bouncing off the surface, and then you can have effects like roughness on the surface, and you get a way more realistic effect. Here, talking about roughness, we have a thing that is called a texture that's called roughness, and this tells you how rough is the surface. So it is as easy as it is. And how rough is the surface? Well, white is rougher, it's more rough, and black, of course, is not rough. So that means that these darker stripes are a bit more shiny. Makes sense. It is kind of some color paint that will definitely reflect light more than the asphalt. And we can, for example, in the standard Unity shader, standard shader, this is a material. You can just right click, create, and then you create a material. This is the folder here, shown in the project of Unity. And you have here the material. Here is the preview, and I drag and drop it in here. And now we see the street, how it is. But you see that the street has not really a structure. Everything is kind of like plastic. We can see smoothness. And the source is the metallic alpha. We don't have a metal map, yeah? The first map is always albedo. Albedo means a surface is reflecting a color. And that is what it is. It is painted on. The second thing, metallic, would mean we can drag and drop the roughness into the metallic, and look what happened. Now everything looks dark and more glossy. The reason is that's what metals do. They reflect stuff, and they tint the reflection in the color of the metal itself, so of the albedo. While non-metal or dielectric surfaces usually also reflect stuff when they're polished, but they are not tinting the reflection. They keep the reflection original color, kinda. But metal is special. And we see it is here. It makes a difference because the stripes here, it is less metallic because darker, less metallic, and white is more metallic now. So more, see, it changes the tint of the reflection in that moment. Doesn't make sense, of course, because a street is not a metal. So in this case, no metal map, because if the slot is empty, then the slot is black. And black, like we already learned, is 0. So there is no metallicity. But we have we smoothness? No, we have roughness, because the industry standard is texture packs in roughness. How do we achieve smoothness? At first, we switch to albedo alpha. Too glossy. Because now the smoothness is 1. Why is the smoothness 1? Because there is no transparency. So the alpha channel is white, and white is 1. Way too glossy. What do? We We look into this albedo texture, and we drag and drop the roughness in, and then we have things here. We have W for creating a fully white texture again, and we can invert it to black, like we already learned. R is just resetting it. But if I take the roughness and I invert the roughness, what is the inverse of rough? It is smooth. And this is smoothness. Now this texture is not telling us how rough the surface is, but how smooth. The street, of course, is not very smooth, so it is dark. But the paint is smooth, so it is bright. So bright is always a yes, dark is a no. And then I just click on resave. And what does it do? It creates a new texture. Why? Because this is a JPEG, and we create now a PNG. So we get an extra channel. Unity now checked. Oh, there's something new. JPEG, PNG. So we take the PNG. Whoop. And now we have the correct roughness. The roughness map usually is a non-color. That is important for something like Blender. Also a normal map. It is not really showing us colors, but mathematical informations for our shaders. So when we drag and drop it in as a normal map, then it looks a bit weird, but it also said, oh, this texture is not marked as a normal map. Fix. And now we have the surface structure. In Blender, it works a bit different. If I'm in a project in Blender and many things, there's a street, and we go in the shading, then you have this tree. This is the albedo texture going into the base color, and then you have the normal map going in the normal. But you can't just like put it here in the normal. You would get weird effects. It needs to go in the color of a normal map node and then normal to normal. So it converts. And while the albedo texture, of course, is full of colors, the color space is sRGB with most of them. We set the color space of the normal map to non-color because it is information. It is not color. You see it as colors, of course, because it's a texture. It is a picture. It works like that, but it wouldn't make sense. The height map, like we could use it, but it is not very needed. Normal maps usually also give you grain and bumpiness already. Occlusion means shadows. Where the light is not going, you have kind of shadows painted onto the texture that will fade when exposed to light sources. And a detail mask can just overlay stuff on your texture. Emission, yeah, easy. It makes bright, but doesn't make sense that a street would glow. You can also grab a texture as the emission color. Then it would glow with the intensity of this field, and it will glow the texture from the texture you put in here. The tiling is just, like I said, now we crunch it together or we stretch it apart with tiling. So usually you have a 1-to-1. It's kind of the ratio of the texture. So positive numbers are stretching it because so many times you have the same texture here now. And if we go below 1, then we just have a little part of it. Offset is kind of self-explanatory. You can, for example, animate something like this. Imagine we are going on the road and then we are driving, animating the texture, and now you don't need to animate the road or what else there. Secondary maps is also just like detail albedo. You can overlay textures on there. Anything that is important here, specular, highlights, reflections, and there's just effects. Enable GPU instancing, turn it to yes if you use this texture more than once. And on the object used more than once, you definitely need to then go and set on the static, the batching static off. Then it would not do something like, oh, and this object gets the texture, and this object gets this, and this object. It would say like, hey, who needs this material? And the meshes that do need this material will kind of point the fingers up and they get it. It will be handled in a single draw call then. Draw call is that called, but we don't want to go too deep into how all that works. I just want to give you an overview. You can, of course, change. For example, oh no, the material is broken. No, it's just the emission. I have, for example, an add-on called Bakery, makes fancier lighting, needs an own Bakery, needs an own shader. We have standard Bakery, what is kinder like the standard shader of Unity, but a bit pimped. You can do more. What is different here? You could say, for example, if we drag and drop it here on the street, as there's a slot in the mesh renderer for a texture. If you are wondering why it's so blue, that's because of the light information in the map is wrong here, because I'm building stuff from scratch and need to bake the light in the end. Just a little throw in. If you're bugged by weird lighting, for example, if you drag and drop stuff from Blender into the scenery and you keep it packed as a prefab, because every FBX 3D file you get into your project is kind of a prefab, so a box where everything is in, and if you unpack it, it is kind of dispatched from this original state. But if you keep it in the state, visible by all the blue stuff here and also by the main icon in the beginning, like here, learning project. It's called learning project because it is a very old Blender file that just was called like that because I was learning something and developed something out of it, a little hobby project. Then you could just like work in Blender again and override the old data, and then everything is updated. But if you change the rooms here, the overall geometry and stuff, then if you come back, when you come back, you will see that the lighting will completely be all over the place because the mapping of the textures everywhere changed because the whole size of the thing changed, the topology changed. That changes kind of the UV map. UV map is just the underlying plan how to take a 2D texture and put it on a 3D object. The thing I already mentioned with cutting the stuff in parts. And it is called UV because it is kind of an XY on 2D. Why ever? Because U and V were still free, I guess. If you're bugged by weird lighting and you don't want to bake now because you're still applying stuff, but you're bugged by weird shadows where they shouldn't be, just go to your lighting tab. Just go to your generate lighting and use this clear bake data, and you're fine. If you bake the light again with this here or with in my example with Bakery, I click here on render when I set up everything. You should know what you're doing here. Then it takes some time. And when it's done, you can auto-generate. Then it would always, on changing things, update the baking in the background. But this is very unperformant. I wouldn't do that. After that happens, you should see if the files get too big. You see it here. Now I just deleted the data, so it's 0 bytes, but it can be very big if you're not careful. Maybe you crunch it down. It's always a good thing to start baking higher maps like here, 2K, and then crunching them down. Then you're kind of super sampling. You're rendering with more information, pressing it to lower information, but you create smoother results. Sometimes the baking is not working because a light is not functioning, and you might ask yourself why. Well, for example, if you use stuff like Bakery, the objects definitely need to be in the Bakery shader. And the light sources also need a bakery light, in this case, a point light. If you have a spotlight, then you definitely need a cookie texture that says a light cookie is kind of you paint the influence of the light. But I had the problem, for example, that the lamp was just not working, and I was thinking like, why? Well, two things that can help. You get yourself the light cookie and click on right click, re-import. It refreshes the ID of the thing. If you're always copying around much stuff, sometimes it might be that the GUID that Unity gives to everything get confused. And then you re-import it and it's working again. Or you use, for example, bakery. What do we have here? Utilities, clear cache. Clear cache also can help. If you do these two things and bake again, it is like the blowing into the cartridge of the old console. Should work again. There are just many little things that can help making your stuff work again. And over time, you will find all those out. Yeah, the shader, for example, usually this object would just be rendered from one side, but you have here the option to say, no, it's two-sided. That is very, very handy for leaves on trees or very other thin things like planes that are just showing up textures. But if you do need to see something from inside or from the other side, this double-sided thing is very helpful. The rest is just stuff like, I, for example, use the spherical harmonics and the monospherical harmonics. So here automatically we see nonlinear spherical harmonics and we enable the light specular. This is what I need. This kind of enables extra channels that will be needed for bakery in the end to bake the lighting, to make it appear physically correct. But this is definitely a topic for another day. I just wanted to show you a bit more in depth about what are textures. And the answer is just painting on the empty objects, because they would look shitty if they would be just naked. Before we had those textures, we kind of painted the model itself. There where information was kind of saved in the model on each little dot or vert, of the mesh. Which color are you? And from there, blending to the surroundings, the color value was, It was okay when you have very simple models and you just need a few colors here and there. But if you get objects in the thousands, tens, thousands, 100 of thousands of little single vertices, then, yeah, I think you get it. So, we learned that we can just invert the standard roughness to get smoothness and bake it in here into the albedo to get the effect. Why the metal usually is the standard for the smoothness? It's just a decision of Unity. If you, for example, when should you keep it with, if you have a metal map, usually a metal map is this, just shift and drag and drop does this. Usually your metal map is not existing, yeah? But if you have a metal map, you don't need a metal map. You can just drag and drop roughness, invert to smoothness, and then save this. But then you have 3 lost channels. But if you already know I need this, and the roughness is just a value from 1 to 0, black to white, on one single channel, put it in the channel. It's one texture, but 2 functions. If you, for example, have 20 different portraits of a tree in a world. But every portrait should be the same surface structure. Just save low quality JPEGs of every of the 20 pictures, and then grab an empty texture, because the picture is not a metal, and drag and drop, for example, the roughness, inverted smoothness, on the metal map, and use the same texture for all the 20. Why? Because one texture, don't using the metal map, but now using the smoothness, will work for all the 20 portraits of the tree. But if you would just drag and drop the texture of the smoothness into the painting, then the problem would be you have 20 times the same thing. That 20 times makes your JPEG to a PNG, makes it fat, makes it not very efficient. It would just save, some computation power. This is just tricks how you use the whole knowledge about textures later when you implement it to your own projects, like here. If I put a tree here, I create a material, call it for now just tree, drag and drop it in here, the tree, and then I will put it here. Oh, we see a problem. Because it is white, but it should be black. What is the problem here? It's Unity wants to know that alpha is not something as an information or so, it is a transparency. And then you can do this. And the shader, standard shader, also thinks that it is opaque, but it is now a cutout, because there is no background. So it's the mode of the rendering. You can also put it to fade if there are something like half transparent things like glass. But here is something, someone did a very sloppy cutout. So we better not fade, we just cut out, because more smooth. Also, if you have these textures, you can do something like you mark all of them. You can just keep the not used textures in there, because if you make a build, just the stuff that is used here in the hierarchy in your project will also kind of have an impact on your project, while these things here are just making the project file bigger and bigger, but not the resulting program. Now I have marked all these textures here, and I can scroll down, and I see the max size is 2K. It doesn't make sense because it's a 1K texture. Then I could say use a crunch compression. Now it compresses, and in the VRAM it will decompress, but it will be tinier download sizes, for example. And ISO level, I usually like 4 and 90 compression. This has something to do with looking sharp when angled from the sideways and stuff, but doesn't matter now. So here we have a default build, the Windows, the computer monitor's usual Windows, and this is the Android build. You could say like we override the default compression because we don't have so much space on Android phones and stuff. So the 1K goes down, for example, to 512. And if you far away, and it doesn't matter, why not even 256? Yeah. We could keep it like that. And now we're compressing it. That saves memory. Download size. If you really want to make the texture smaller, no crunch compression, and we go down to 512. Now it's, we apply, it is just 512 in the download and in the later project. But if you use crunch compression and accept now, then you will you will crunch it down, but it will unfold like it was before nevertheless. So with this here, we have, let's do this for now. And I hope this was helpful. If I missed something, if you have questions, just ask in the comments. There are more of those maps, different attempts to present those values here, those physical-based values, like glossiness, is another attempt. If we look into the physical principled BSDF of Blender, it is bidirectional. Is it there? No, it's not explained here, no? It is a bidirectional surface, blah, blah, blah distribution function. So it is kind of the math of what the surface should look like. We have also here the base color. We have the metalness, the roughness. Here's roughness, not smoothness. We can use the values here, or we have an input like colors, or here non-colors, normals, and then we have more here. Diffuse. My mouth is fuzzy. Subsurface is this thing that is nothing for real-time stuff, like in games. That is more a render thing. Subsurface is kind of light that goes into a surface and scatters under the surface and back out of the surface, and the wavelength of the different wavelengths are scattered differently. How much, for example, if light hits your skin, the red values get scattered more. So you set it usually then to 1, and you say how deep can it scatter, 5 centimeters here, and also the radius of, for example, R, G, and B. The standard is the human skin with subsurface scattering. So red value fully 1, green at least 20%, and blue just 10%. That's how your skin would reflect swallowed light back. This is with subsurface scattering. But this is usually a thing, as an effect that you choose, wisely, because it is heavy. Specular is just another way of creating reflections. IOR is the index of refraction. Every material have a different index of refraction, but usually with materials, it's not differing too much. You can use it for fancy effects, like chromatic aberration with light going through glass and stuff. You can kind of split the channels and give every channel a slightly different IOR, and then add the channels again to a shader, and then you have a super fancy glass. But how strong is your PC? Transmission, going through. Code is kind of like if you have like a colorless paint on a surface, then you usually would have a reflective thing on top of an existing material. This is the clear coat. Sheen is for if you have fuzzy materials. If you have fabrics, then you usually have tiny, tiny, tiny hairs on the surface that kinder reflects the light. And this reflection is faked with sheen. Emission is the same as we had in Unity, which color should be reflected in which strength. And thin film is comparable to clear coat, but it is more aiming for oil. How thick is your oil film here in nanometers? And the index of refraction with 1.33 is also it is more like water here. Water would be around 1.33 in my, as I remember, but I wouldn't put my hand on fire for that. But yeah, the principal BSDF is the standard shader you get in Blender. I just wanted to show you the differences from game engine to a program that creates your assets. You know, it goes here on the surface. You also have different things. Volume would be if you're doing clouds, but that's usually a thing also more here in Blender. Those volumes are not translating to normal game engines. And displacement would just be something like normals. It would, but it would be physically correct. It would not just look like it. It would really displace the object. Yeah. So your object with a topology is not changing, but a texture can say on kind of pixel-wise, yes, change the output. But I hope the little deep dive, the longer we are in, the deeper we dive currently, obviously, into the science of materials. I should tell you one thing. Many game engines work differently with normal maps than, for example, Blender, because you have two standards. You have the standard of DirectX, and you have open OGL or so. If you need to translate from one program to the other, you could, in Blender, you could just do the same thing. You know, green. The green channel, or the Y value of the whole thing, inverted. See, it's nearly not a difference, and often you don't see the difference. But if the normal map looks somehow weird, try to invert the green, because that changes the DirectX standard from the OGL standard. I think that Blender uses OGL, and Unity should use DirectX. I always mix the stuff, but it's not important to know everything, you know, out of nothing. It is more important to understand the overall topic, and if needed, know where to look. Where's the problem? If the surface looks weird, it could be this problem, that normal maps work different in different engines. And why? Just because to make the life of us, game developers, even more complicated than it must be. It's already complicated enough to create games, but but there are people that are like, they like to divide and make it even more complicated, just because. That is why those little things are added. But yeah, the standards of normal maps are doing nothing more than inverting the green channel. What means that the offset in one direction would be wrong, potentially, of a normal map. What is visible if the normal map is, for example, stronger? If it's a very strong offset from the normal. If you sneak into a new project, for example, a friend gave you a Unity package or so to look into, and then you see, okay, there's an avatar and there's not. What could be the problem? In this case, for example, you see that this character here is flagged mobile, so it uses standard shaders that are already implemented in standard Unity projects. And here, if it is a VR chat project, then probably the shaders might be Poyomi. So when you import the whole thing, also better import a Poyomi version. You can get free Poyomi versions. Yeah, the pro versions are on Patreon. So always check if you have all the shaders that are implemented in a project. Usually, if artists sell stuff, they also write into the project which shaders are used. For example, Mochi shader or so for water and stuff. It's often used. But Poyomi I would say 95% of all projects need this. Because above the standard shader, Poyomi also allows so much more little tweaking and adding fancy dissolve animations and have stuff sparkling or tell how in dark worlds your minimum brightness should be. And you have different channels for emissions and whatsoever. But always when you upload it, lock the shader. Such a complicated shader is very hefty, and a locked shader kind of locks everything that is not used. It bakes kind of the shader. So still, it was not helping. But we have now a Poyomi shader. You can change the shaders. If we have here a little cap, here's part of it. No shader selected. Unlock material. Sometimes Unity comes up with the solution already. If you upload an unlocked Poyomi shader, very often it happens that you have this pink stuff here. Pink means, usually, there is no shader. Cyan blue means I'm loading. Pink is there is none. So this already helped. We have here Poyomi Toon. You can change the shaders, and if the channels correlate, they will also take over the textures and what you've set up there. So here, unlock material. So now, with this character, Unity tells us what to do. And sometimes switch to latest toon. When it was a toon in an older version, then Unity is like, do you want to be toon again? But just with a current version. That usually is very helpful. And now you see that these shaders here are not as flat as the mobile shaders. You instantly have more of an effect. Yeah. The eye lens keeps standard shader because that's just the lens above the eyeball to reflect a bit and to be shiny. I would even say if you have something like that, you could also just use a standard shader, but specular setup. My mouth is fuzzy already. Then you can tweak around a bit to create the effect you want. Here is usually a fake light. That is the surrounding light. If you wanna, here it would be looking through. Nope. And here fully. You can just tweak until it's to your liking. But yeah, like that you can solve problems with non-existing characters. Usually it's a shader problem. And if you have any questions, come to me and ask. I see you in another video. I see. I'll keep it like that. I want to make a fancy effect here.